Imagine a vast web of metal and wire stretching across continents, connecting power plants to every home, school, and hospital. This is the energy grid, the circulatory system of our modern world. Without it, life as we know it would grind to a halt. The grid moves electricity instantly from where it's made to where it's needed. It's made up of three main parts: power plants, transmission lines, and distribution networks. Power plants generate electricity from sources like gas, nuclear, wind, or solar. Transmission lines, those tall towers across the countryside, carry high-voltage power over long distances. Distribution networks bring electricity directly into our buildings. The entire system must be perfectly balanced. Supply must always match demand. Too much power can overload the grid. Too little causes blackouts. Grid operators monitor and adjust the flow of energy every second. Think of it like a river system. Power plants are the springs, transmission lines the rivers, and distribution lines the streams reaching every home. Every part must work together seamlessly. A problem in one area can ripple across the entire network. Europe's grid is among the world's most complex, linking dozens of countries. This interconnectedness allows countries to share electricity and support each other in times of need. The grid is a silent giant, working tirelessly behind the scenes. It's the backbone of our daily lives, powering everything from light bulbs to life-saving equipment. Understanding the grid is key to understanding how our society functions, and as we'll see, keeping it running, especially in winter, is a monumental challenge. Winter transforms the energy grid into a high-stakes battleground. As nights grow longer and temperatures drop, our demand for electricity surges. The grid faces its toughest test, pushed to the limit by cold, darkness, and storms. Ice and wind can damage power lines and topple towers, while flooding threatens substations. These aren't just possibilities, they've caused major outages before. Winter also affects how we generate power. Solar panels produce less, rivers may freeze, and fuel supplies can be disrupted. The grid is attacked on two fronts: higher demand and greater risk to supply. Engineers must prepare for nature's worst, ensuring the system can withstand the season. Our modern preparation echoes ancient survival, stockpiling energy instead of food. The stakes are higher than ever. Our interconnected society depends on a robust grid. Each winter forces us to innovate and strengthen our energy systems. The annual trial of winter is a reminder. Resilience is not optional. Only by planning ahead can we keep the lights on when we need them most. Winter's core challenge is balancing supply and demand. On cold evenings, millions turn up the heat and switch on lights, creating huge spikes in demand. Grid operators must anticipate and meet this surge. If they fail, the system risks collapse. Emergency measures include importing power from neighbors or firing up peaker plants, which are costly and polluting. A shortage isn't just inconvenient, it can shut down hospitals, communications, and water systems. That's why governments and utilities plan obsessively for winter. Recent years have added new complications, fuel supply disruptions, and geopolitical tensions. A sudden loss of gas imports can cripple electricity generation just when it's needed most. The balancing act is now an engineering, economic, and political challenge. Europe's interconnected grid helps, but it also means problems can spread quickly. Preparing for winter is about more than keeping the lights on. It's about safeguarding society. Every winter, the grid walks a tightrope between stability and blackout. The risk of darkness is real, but so is our ability to adapt. The future depends on how well we manage this delicate balance. Europe is embracing wind and solar power in the quest for clean energy. Giant turbines and solar farms are transforming the landscape and the grid. Renewables offer energy independence and lower emissions, but they're unpredictable, especially in winter. When the wind calms and skies darken, output drops just as demand peaks. To manage this, we need new strategies, massive batteries to store surplus power, and smarter ways to use electricity. Demand-side response pays big users to cut consumption during peak times, easing strain on the grid. Stronger interconnections between countries let regions share renewable surpluses. A windy day in the North Sea can power homes in Germany. Spanish sun can help France. The renewable transition is about more than new technology. It's about building a flexible, connected grid. Europe's future depends on making renewables reliable, even in the depths of winter. The challenge is great, but so is the promise of a cleaner, more resilient system. By adapting, we can turn nature's variability into our strength. The grid of tomorrow will be smarter, greener, and more robust. To face future winters, Europe is overhauling its energy grid. Billions are being invested to modernize infrastructure and prepare for a renewable future. Old power lines are replaced with high-capacity superhighways that move electricity efficiently across long distances. High voltage, direct. Current lines connect remote wind farms to cities and industries. Digitalization is transforming the grid. Sensors and software give operators real-time control and early warning of problems. Smart grids integrate renewables and enable new services like demand-side response. Energy storage is the missing piece. Giant batteries and pumped hydro projects smooth out supply and demand. Green hydrogen offers another way to store surplus renewable energy for later use. These investments are the shock absorbers of the future grid. The goal, a system that's efficient, reliable, and ready for anything winter throws at it. Europe's energy revolution is happening quietly, but its impact will be enormous. Every upgrade makes the grid stronger and more resilient. The work is urgent. Climate change and new energy demands won't wait. The grid's transformation is key to a secure, sustainable future. History's blackouts have taught Europe hard lessons. In 2006, a single power line shutdown in Germany triggered a cascade, plunging millions into darkness. The crisis exposed the fragility of an interconnected grid and the need for better coordination. Since then, operators have improved communication and emergency procedures, sharing real-time data to prevent small problems from escalating. The winter of 2022-23 brought a new test: gas shortages and fears of rolling blackouts. Europe responded by cutting demand, finding new fuel sources, and accelerating renewables. The lesson: over-reliance on one fuel or supplier is dangerous. Diversification and flexibility are essential for energy security. Every crisis has spurred investment in wind, solar, and efficiency. The grid's resilience depends on learning from the past and adapting for the future. Failures are blueprints for success, if we pay attention. Europe's energy future is being shaped by the lessons of every blackout. The Nordic countries show what a resilient, interconnected grid can achieve. Norway, Sweden, and Denmark share energy resources through tightly linked networks. Norway's hydropower acts as Europe's battery, storing energy when there's a surplus and releasing it when needed. Undersea cables like NordLink and Viking Link connect these nations to the rest of Europe. This allows wind power from one country to be balanced by hydropower from another. The result: a stable, reliable system that reduces the need for expensive backup plans. The Nordic model proves that cooperation makes everyone stronger. Europe's energy resources should be seen as shared assets, not just national ones. A sunny day in Spain or a windy day in the North Sea can benefit the whole continent. More connections mean greater resilience to winter and renewable variability. The lesson from the North: in energy, unity is strength. By working together, Europe can build a grid that withstands any challenge. The future is interconnected and resilient. As winter 2026 approaches, Europe is racing to fortify its energy shield. Gas storage is being filled to the brim, providing a crucial buffer against supply shocks. New wind and solar projects are coming online at record speed. Existing power plants, including nuclear and coal, are kept ready as backup. The long-term goal is clean energy, but short-term reliability is essential. Reducing demand is just as important. Public campaigns and incentives for efficiency are making a difference. Millions insulating homes and upgrading heating systems help cut consumption and emissions. Grid operators are stress testing the system, running simulations to prepare for worst-case scenarios. It's a dress rehearsal for winter, ensuring everyone knows their role in a crisis. The strategy is multi-layered: secure supply, reduce demand, and plan for the unexpected. Europe's preparations are about more than just surviving winter. They're about building confidence. The goal: a continent ready for anything, with the lights on and the heat running. Winter is coming, but Europe is ready. The energy grid is the invisible backbone of our lives. It powers everything from hospitals to homes, factories to phones. A resilient grid is essential for prosperity, security, and well-being. Preparing for winter 2026 is an investment in our collective future. The clean energy transition demands innovation, engineering, and international cooperation. The rewards: a future powered by clean, secure, abundant energy. This fight isn't just about climate, it's about economic strength and social stability. And we must keep building interconnectors, investing in storage, and accelerating renewables. Energy efficiency and public awareness are vital. The journey is long, but every step strengthens our society. Europe's grid is a story of connection, physical, political, and human. By building smarter, stronger networks, we prepare for more than just winter. We're creating a sustainable, hopeful future for generations to come. The lights of our civilization depend on it.